Hi folks. Well, this is going to be kind of a lengthy tutorial about how to, an introductory tutorial about how to use physics and how to assign physics in Blender, and also how to create object arrays. And here is an array of cubes, and we're going to see how to implement some basic physics in Blender so that you can create animations and begin to make some things work. And what we're going to hopefully end up with is something similar to this. And I'm going to hit the activate button, P, and then I'm going to fire this ball into the cube block, and you get to see what happens. It's kind of cool. Alright, so I've just fired a cannonball into a block of cubes, and it's an array block, and we're going to see how to generate these blocks. And once again, this is kind of a lengthy tutorial, but I think it'll be informative. You'll get to see how to set up coordinate systems and a lot of basic issues that we have to deal with in creating any kind of system of objects that we want to perform animations or basic physics on. Okay, so for now, let's just start out from scratch. And so what I'll do is I'll load factory settings, which gets us back to the original default with the basic cube. And the cube has dimensions. Let's see what its scale and dimensions are. I'll hit the N key. And right now its dimensions are 2 by 2 by 2. So I'm going to change that. I want it to be a bit smaller, so let's make it 1 by 1 by 1. Alright. And what I'm interested in is making an array of these cubes, because I kind of want to make a little building, a group of cubes. So we're going to see how to add modifiers to do that kind of a thing. First, let's position the cube over to this corner here, and we'll do that by just typing in this a new transformation, say -5, -5. Whoop. And we want it to be above the plane, so let's make it 1. Okay. So now it's sitting here. We have a cube. It's above the plane of the scene, and it has a dimension of 1. Its origin is at -5, -5, and now I can start to make an array. But in order to make this array, we need some kind of a reference coordinate system to make the array. So what I'm going to do is I'm going to add an empty coordinate system. So let's go ahead and do that. Add empty. And we want to position this empty coordinate system so that subsequent duplicates of this cube are aligned along a certain axis. So let's see. Let's go ahead and do that. And we will say, let's say we'll position it at -3.99, and then -5 and 1. Okay. So I've positioned this empty coordinate system in a location that's just to the right of the original cube. Now I can begin to create an array. So let's select the cube again, and what we're going to do is add a modifier. I should move this over so we can see all of the options. I'm going to add a modifier, and the modifier is the array modifier. So I've added one modifier, and as you can see, it right away added a cube because there's a fixed count of 2. All right? And it offset the object exactly 1 unit to the right along the x-axis. Just like the relative offset is indicated. However, what we want to do is we want to offset it based upon the empty coordinate system. So I'm going to select object offset in this case, and I'm going to select empty. And now what we have is a duplicate cube which is offset and scaled. So, but we don't want it to be scaled like this. So in order to fix that issue, what we want to do is go back to the empty coordinate system, and we're going to set our scale factors to be 0.5, tab, 0.5, tab, 0.5. Okay. So now we have an object which is offset from the coordinate system by a certain amount. Let's go back to the cube and turn off this one relative offset. We don't need that. Just uncheck it. And now what I have is an additional cube which is offset by a small amount based upon the empty coordinate system relative to the original cube. I can increase the count. 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so now I have 11 cubes in an array that are offset relative to the original cube, depending on the empty coordinate system that we've assigned. Now this is interesting. I can do some funny things with this. I could, for instance, if I change here I am located at the empty coordinate system. If I change the orientation of the empty coordinate system, I can rotate the subsequent array objects. That's kind of neat. I can rotate them in the y direction. That's kind of neat. I would like it to be finer control, but I think you get the idea. So I can rotate about the y-axis, and I can rotate about the z-axis as well. So I'm sure you can imagine different applications for this kind of behavior. All right, but for now, we don't want any of these fancy rotations. So we'll just say 0, 0, 0. Okay, you might wonder why I entered in 3.99, negative 3.99 here, instead of just an offset of 4. Well, the reason for that is because we would like to have a small gap, a very small gap between each of the objects in the array. Okay, here's the small gap. And that is because in the future, we want to establish this object as being a solid object. And if there isn't a tiny gap here, then the collisions or the contact will interact, and it will cause the object to basically explode on its own volition. So we leave a tiny little gap there in order to allow for the object to be solid without exploding itself. I don't know how else to explain it, but I think that's probably sufficient for now. Okay, so next we want, now this is one dimension, now we want to expand along the second dimension. So that's not too hard. All we have to do is select the cube again. Over here, I'll just select it here. And we want to add an additional array modifier. Well, but before we do that, we have to add an additional coordinate system for us to be able to expand along the y-axis. So let's go ahead and add an additional empty coordinate system. So here we go. Add empty. And now we need to position it approximately, well, exactly 1 cube in the y direction, leaving a small gap. And so let's do that. So what's its location is going to be let's say -5 in the x direction this time, -3.99 in the y direction. See that? And then, of course, 1 in the z direction. Okay, so now we have that coordinate system. We may have to set the scaling. I think so. Okay, so this is our empty coordinate system, oriented one block, 1 unit, plus a little gap in the y direction. Okay, and so now we'll go back to the original cube, and we'll add another modifier. So we have a modifier here already, but we're going to copy this modifier, and then we obtain an additional modifier. And when we copy the modifier, it just applies it as the previous, so it's extending out the x-axis. But that's because it's working on the original empty axis. Let's rename this empty 001 axis. Rename. To empty, we'll just say empty y. How about underscore y, just to make it easier to read? So this second empty axis is empty y. And now what we want to do is go back to the cube, and we want to assign that to the second dimension of the array, empty y, and boom. Here we have a crazy looking new array duplicate. And the reason it looks like this is because we haven't set the scaling correctly. So I'm going to go ahead and set the scaling for the array, and we should set it to 0.5, 0.5, 0.5. Okay, zoom back in, and look at this. This is fantastic. Now we have a plane, basically a plane of cubes that are all the exact same size, and they're separated by a tiny little gap. This is fantastic. Once again, if you change the rotation or displacement of the array, you can affect the array, the entire object. If you change the displacement or the rotation of the empty axis, which the array is defined upon, then we can watch this happen. For instance, if I change the x coordinate or the x value, then you can see that the whole plane sort of curves up. It looks like Inception. It's awesome. You can also change the y coordinate and bend it this way. And we can even change the z coordinate. So you can imagine the possibilities here. You can create objects that are quite complicated in an array sense with a pretty simple set of commands. The only way that you can do this is by using this empty coordinate system technique. All right, that's why I'm showing it to you. But for now, we don't want to do that. We want to just make a very ordinary looking cube. So 0, 0, 0. That's all we want. Okay. So, but we need to, once again, we need to extend this in the third dimension. So, we're going to have to add another empty coordinate system in the third dimension and an additional array. So we're going to operate on the first array, makes the second array then makes the third array. Okay, here we go. So the third array, we're going to add an empty coordinate system along the z-axis. So let's go add empty. And so now I've added an empty coordinate system, and let's just rename it right away. Empty z. And now let's set its location to be offset in the z coordinate. So this time we go -5, -5. Something I did wrong. I hope I didn't mess something up. -5, tab, -5, tab, 2.01, and actually, how about 001? And something didn't work because it just says 2.00. 2.001. Enter. Okay, that's fine. So now our reference coordinate system for the array is aligned at just above the original cube with a tiny little gap once again, 2.001. I think we can make the gap a little bit bigger. So let's make it 2.01 instead of 001. Enter. All right. And now we have to go back to the original cube, and we need to add a new array. So this is the empty y array. We're going to copy that again, and that's going to provide us with a new array. And this new array is going to be offset using the empty z object. Boom. Oh, I didn't scale it. So empty z, we've got to scale it. 0.5. 0.5. 0.5. Okay. And so there you have it. We have a cube. An array of cubes as a cube with a small offset between each cube. And boy, it's fancy what you can do at this point. If I take the empty z coordinate and I do some rotating, wow. All I can say is wow. And in the y direction, and possibly in the z direction at the same time. Now, you get the idea. Take it back to 0, 0, tab, 0, tab. I can modify the original coordinate system and it will affect the remaining systems. Okay, x, y. So you can do some really interesting things with this array object modifier. All right, pretty neat. So there has been some question about undos. I probably have done too many things. We'll see if I can undo it back to its original. Undo. I go object, undo, object, undo, object, undo. Oh, object, undo, object, undo, object, undo. Aha, we're getting back. Object, undo, object, undo. For some reason the keystroke doesn't work. You have to use the mouse. I don't know if I'm doing something wrong or not. Undo, 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 undo. Tedious, but it's working. Undo, undo. Okay. And now we're back to a cube. Okay, so we've set up some empty coordinate systems. We've created an array, and the array is now a set of objects. Let's quickly do a couple things. Let's move the camera away. I'm going to left click on this arrow axis to move it this way. Left click on this axis to move it this way. Okay, so we have a cube, 1,000 cubes that we've just created using the array function. Just to be a little bit more detailed, let's look at some translations. I can take the y-axis translation and I can adjust it. It's set at 3.99, negative 3.99 right now, but if I were to change it, what happens? The array gets expanded. Okay? So hopefully that makes some sense. I can change the z and the array gets adjusted based upon its reference coordinate system. Okay? Same goes in the x direction too. So let's undo, 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 undo. And I think one more. Undo. Oh, actually it's a couple more. Undo. Two more. All right, now we're back. -5, negative 3.99, 1. All right. Okay, so that ends part 1 of the tutorial. In the next part, we're going to see how to apply some simple physics to this cube, and also how we're going to be able to break the cube apart into its individual components so that we can make some interesting effects like an exploding cube and stuff like that. All right.